Welcome to Unit 10 Ant Escape Level 0. In this lesson, we're going to put together a project that combines all of the mini lessons from Unit 9. We'll also pull in some material from Unit 7, and then we'll probably pull in some other things that you've never seen before, just because that's the way we do it here. So, learning objectives. We're going to create a sprite that acts as a sensor to detect other objects. We're going to look for reactions from objects colliding. Now, they won't be physically colliding. It'll be more of a abstracted collision between imaginary objects in your program. And then we're going to use sprites as triggers to switch levels. We'll explain all those terms. And then we're going to use the wait until control block to help us with those triggers. So let's look at the program and see what this looks like. I'll make it full screen here. And let's go ahead and click on play. So we start on the first level, and you'll notice we have a little person running through the level, and I kind of put the graphic together, which explains why it doesn't look very good. No big deal. What's important is that you can see I'm running through the maze, and if I try to go up, I can't go through the wall. If I try to go left or right, I can't go through the maze walls. If I try to go down, I can't go through. That's the major characteristic I want you to see. I just drew these mazes here in Scratch. Didn't spend a lot of time drawing them because that wasn't my goal. My goal is just to teach you how to program. Now, notice when I hit that blue arrow, you can see that the blue arrow, excuse me. You can see that it switches levels here. So you can go through and redesign some of these levels as you get finished with the project. One thing that you should note is we can notice that the player's going through the levels here and not touching. And sometimes you'll see that the runner sprite down here overlaps the maze. Okay, because what's taking place is that this sensor sprite right here is actually detecting the wall colors, and it's stopping the sprite from moving left, right, up, or down whenever a particular color of the sensor is touching the walls right here. Okay, so we're stopping its ability to actually go through the walls by not allowing it to move. Say we're going up, if the green's touching the brown right here, and we're trying to go up, what we do is we stop its movement on the y-axis so it can't go up, which gives you the sensation that the wall is physical and doesn't allow you to move. And the same thing as going down. If we have the blue sensor here and we're trying to go down and it's touching the maze is its own sprite right here, and we're going down, you'll notice that it doesn't go through the wall of the maze, okay, because we're stopping its ability to move down on the y-axis. And I broke the code up over here in two different sections. And you can see right here, when I press the up arrow, if the green color, which is the top, is touching the brown, which is the brown part of the maze, and it's touching the maze, I'm doing a double conditional check right here to make sure it's touching the color brown and touching the maze, because we might have a scenario where you change some of the stage colors, or you have additional sprites that have the same color brown, same RGB values of this brown right here, and if the sensor's touching it, it could potentially stop this the sensor from moving because it's touching that same color. So we're checking also to make sure that this brown is part of the maze right here. Okay, so it's just kind of helping make sure we're actually touching the right object to stop us from moving. Then here you can see if this is true, then we change y by 0, which does not allow us to move up. And then change y by 3. If it's not touching it, it allows us to move upwards. Okay, that's all that's going on. Now you notice the sensor is right here, but you can't really see it. If you look real close, you can see that the sensor is barely visible. What I've done is I've ghosted it to 90%, so 10% of it's visible. I could have gone all the way to, say, 99%. It wouldn't affect the outcome of the program, but I left it at 90% just so you can barely see the sensor sprite while you're working on this, which allows you to kind of get some sort of identification of where it is as it moves around on the screen. Okay, let's look at something real quick. I was talking earlier about how the sprite was invisible for the sensor, and the runner sprite is just sitting on top of it. These functions right here for the sensor control the movement by allowing you to use the directional controller, or excuse me, the XY controller that we had programmed previous, by manipulating the X and Y axes right here. Okay, the difference between the previous XY controller and this one is that we have some sort of abstracted resistance where it can't go through particular objects by not allowing us to change the values on the X or Y axis if it has a condition that's true that meets the criteria for some sort of resistance that we want to, simulate. Right here where it sets the ghost to 90%, if you want to see your sensor sprite while it's working, and you're certainly more than, how should I say this? You can do this if you want. Okay, let's set let's just set it to 0. Now double click on this. Now the sensor sprite is visible, and I can move the sprite around, and you can see the sensor, how it manipulates on the screen, and you can get a good feel for how the sensor moves through the maze. It actually looks a lot smoother with the sensor than with my horrible runner sprite down here. The runner sprite, all it does is it goes to the sensor in a forever loop, so it's always going to go to the sensor sprite right here, and then we just tell it to change its direction for right, left, up, and down based upon the arrow keys that get pressed by the user. And that's all it does. If you want to, you can change the sprite out and put something else in there. It doesn't even have to be kind of like a maze runner. You can almost make like a driving game or some sort of game that's top-down perspective. Same concept. We're just programming this sprite to go to the sensor, and since the sensor's ghosted out, it makes it appear as if you're actually moving with the runner sprite. The maze sprite, all this does is it just changes its costume based upon the level, and the level message that gets sent to this comes from the arrow sprite, and the arrow sprite is going to go to specific XY coordinates, and I had to figure out where these were by dragging and dropping the arrow into specific coordinates based upon the map that I drew. And then I just went to the wait until. I told it to wait there until the sensor touches it, and then we broadcast a new level. So let's start this program over, and let's say we're at level 1 right here. I had to figure out where the XY coordinates were. I changed the direction to 0, so it's pointing up. Then I told it to go to these coordinates. Now it's waiting for the sensor to touch it. And when it does touch it, it's going to broadcast this message out. And when it broadcasts this message, level 2, it's going to send a message to itself, and it's going to redirect its XY coordinates to these new locations, change its direction that it's facing, and then again it's going to wait for the sensor to come touch it, and once you touch it again, it'll broadcast to the next level. On the other sprites right here, you'll notice that whenever it receives these messages, it's going to switch its costume, and it'll tell it to go to these XY coordinates. So let's see what this looks like. And just come and run across the screen. And as you touch the arrow, you can notice that everything switched, and then it sent the sprite, the runner sprite, to some new XY coordinates. Now you notice the runner didn't go to new XY coordinates. The sensor went to new XY coordinates based upon receiving this message. The runner is always going to go to the sensor, so we didn't have to program the runner to go there. The sensor gets sent to the new XY coordinates, and that's what sends it to the sensor because it receives that message. All right, let's go look at the instructional material. Let's look at a little bit more detail on our sensor sprite. So when the sensor sprite is moving around, we have the different colors on its body. We have green for the top, blue for the bottom, red for the right, and purple for the left. So whenever the sprite is touching one of these colors that matches the maze sprite, we won't allow that sprite to move through it by basically not changing its X or Y value based upon which direction it's moving. So if it's moving left and right, it's trying to move left, those colors match up, we'll tell it to change its X axis position by 0. And the same holds true if it's trying to go right. If it's trying to go up, we'll change its Y axis position by 0 whenever it's making that collision there between these two colors. And the same holds true as it goes down. Now we do this with this nested if-else inside of an if condition. So whenever the user presses the up arrow, if this is true, then we're going to check this condition right here. 1, are these two colors touching? If that's true, okay, we need to also see if this is also true. Is it touching the maze? So if it's true that both of these are happening, then we will perform the first action, which means the top of the sprite is touching brown, and that brown is part of the maze. So we're saying Y will change by 0, therefore the sprite will not move up. If it's not true, if one of these is false, okay, or both of them are false, it only takes one since we're using an AND condition, will allow the sprite to move upward by changing its Y position. It's pretty cut and dry. The best way to wrap your head around it is to see it in action, and make sure you use the sprites I provided so your colors will be the same as what we're using within the code. And our trigger is a sprite that causes a reaction in the program when a player touches it. We will use this trigger, the arrow, to tell the program to switch to the next level. So whenever the player touches the trigger, as you saw in the video, it's going to switch the level, which will send a message out through the program that causes all the other sprites to change their location or change their costume and their location, all through one message that comes out. And this trigger is able to operate, and there's a few different ways we could do it. I preferred using the wait until block. This just seems the most logical to me. At least I can wrap my head around it. So the wait until block will do exactly what it says. When the code runs down and it gets to the wait until, this piece of code is just going to sit there and wait until whatever condition is inside of it will activate as true. Then once it does that, it goes to the code below, and whatever you put below will take place. Here's an example of the sprites with some of the broadcast taking place, because broadcast is still pretty complicated. So we have our maze sprite and our arrow sprite. I'm going to walk through the maze sprite first. So where the maze sprite receives the level 1 message, which is the same message that arrow receives, it's going to switch this costume, go to these coordinates. I put back 10 layers so it's behind all the other sprites because it is kind of, you know, making the stage, and we tell it to show. Over here, the arrow sprite gets the same message, points in direction, XY coordinates that it goes to, and then right here it waits until it's touching the sensor. So this piece of code is just sitting here waiting until the sensor touches it. And once it's true that it's touching, it sends a message, broadcast level 2, and these two functions, over here for the maze and over here for the arrow, they receive that message, and then this sprite switches to this costume and goes to these two XY coordinates right here. Not two, but just goes to those XY coordinates. And this happy camper over here, when it receives the message, it points in a direction, new XY coordinates. Then again, it starts waiting for the sensor before it'll broadcast the next message. And this process repeats itself as you go through the program. And this is kind of an easy kind of template or, you know, kind of system to follow if you want your program to have multiple levels. Right here, we set this back 10 layers, but we don't do it every time. Just because we don't have a lot of activity with new sprites being added, you might want to add that if you have a lot of additional information being put in there or additional objects. But for our case, just putting it back 10 layers right from the beginning will you know, work throughout the entire program. And that's all there is to it for this unit. Here's your stage. Your stage will have essentially, you know, 3 backdrops, or I guess 4 backdrops, sorry. And then over here on your program, you're going to have 4 sprites. The maze, the runner, the arrow, and the sensor. Didn't see the sensor back there hiding. And then in your maze sprite, you'll have these costumes. And then for the runner, you'll have these costumes. The arrow and the sensor only have 1 costume. Okay, so good luck, and we'll see you in the next unit.